France has made a significant announcement regarding its defense strategy. Reports indicate that the nation is deploying Mistral AI across its military infrastructure to accelerate operational decision-making. This is not just a procurement of new software. It represents a fundamental shift in how the French armed forces approach artificial intelligence. It signals a strategic pivot towards sovereign, open-weight AI models in defense to ensure data sovereignty and reduce reliance on foreign proprietary systems. But to understand the true weight of this move, we need to look past the headlines and examine the underlying technology. What does it actually take to run a large language model in a classified military environment compared to the standard workflows used by civilian companies? Here is the thing about standard AI adoption. Most organizations today use a SaaS model for their large language models. They send their data to a cloud provider, the model processes it, and sends the answer back. This is convenient. It is scalable. But it is fundamentally incompatible with classified military operations. In a civilian context, you accept the risk that your data leaves your premises. In a military context, data exfiltration is not an option. You cannot send sensitive tactical information over a public API to a server you do not control. This creates a massive architectural gap between how civilian AI works and how military AI must work. Now consider the alternative. To deploy Mistral AI within the French military, the architecture must change completely. The model cannot live in the cloud. It must live locally on the hardware. This means the software pipeline requires a complete overhaul. Standard software development relies on DevOps pipelines where code is written, tested, and deployed. But artificial intelligence introduces a new variable. The intelligence itself is data. It is weights and parameters. You cannot just update code. You must update the model itself. This requires a specialized discipline known as MLOps, or machine learning operations. In a standard SaaS workflow, the heavy lifting happens on the provider's servers. The client device is just a terminal. In a military deployment, the client device must become the server. This requires the model to be optimized for local inference. You cannot simply download a massive foundation model and expect it to run on a ruggedized field laptop. The model must be quantized. This means reducing the precision of the numbers within the neural network without losing significant accuracy. It also means pruning unnecessary connections to make the model smaller and faster. These are not cosmetic changes. They are essential engineering tasks that happen before the model ever sees a soldier. This brings us to the pipeline itself. In a traditional DevOps environment, you have continuous integration and continuous deployment. You push code changes automatically. For military AI, you need continuous integration and continuous training. The pipeline must handle version control for the model weights just as strictly as it handles version control for source code. If a model behaves unexpectedly in the field, you need to roll back to a previous version instantly. You need to know exactly which data trained that specific version. This level of auditability is one of the primary reasons France is looking toward open-weight models like Mistral. Closed-source models are black boxes. You cannot see how they reached a conclusion. In a military context, you must understand the reasoning behind a recommendation. Open-weight models allow for this scrutiny. They allow the defense ministry to audit the logic and ensure the model is not hallucinating or introducing bias into critical decisions. Security hardening is the next critical layer. A standard cloud API relies on network security to protect the data in transit. A local military deployment relies on hardware security. This involves secure enclaves. These are isolated regions within the processor where the model runs, shielded from the rest of the operating system. Even if the network is compromised, the model weights and the inference results remain protected within the hardware. This requires specific frameworks and libraries designed for high-security environments. Standard libraries like PyTorch or TensorFlow are powerful, but in a military context, they must be wrapped in additional security layers. We're talking about frameworks that support homomorphic encryption, which allows computation to happen on encrypted data. This ensures that even the system running the AI cannot read the sensitive inputs until the processing is complete. Let us look at the ecosystem supporting this shift. The joint venture between Mistral, NVIDIA, and French state entities like MGX and BP France highlights a broader ecosystem shift. This is not just about buying software, it is about hardware-software co-design. NVIDIA provides the silicon, Mistral provides the intelligence, and the state entities ensure the infrastructure aligns with national security goals. This collaboration accelerates the operational readiness of AI agents for complex decision-making under time pressure. It creates a feedback loop where the hardware is optimized for the specific workloads of the AI, and the AI is optimized for the specific constraints of the hardware. This is the opposite of the SaaS model where you adapt your data to fit a generic cloud service. This architectural shift suggests a future where military decision-making cycles will increasingly rely on localized, high-performance AI inference. The goal is to outpace adversaries in the speed of the OODA loop. OOD stands for Observe, Orient, Decide, Act. This is a military concept describing the cycle of decision-making. By embedding AI directly into the edge devices, the orient and decide phases can happen in milliseconds rather than minutes. A soldier or commander receives a synthesized analysis of the battlefield directly from the AI, rather than waiting for a human analyst to process raw data and send a report back. This compression of the timeline is where the strategic advantage lies. However, this path is not without risks. The integration of Mistral into military operations highlights a growing global trend where open-weight models are being prioritized for classified environments due to their customizability and auditability compared to closed-source alternatives. But this also introduces the risk of model manipulation. If the weights are open, they are theoretically modifiable by an adversary. This necessitates rigorous integrity checks within the CI/CD pipeline. Every update to the model must be cryptographically signed and verified before it is deployed to the field. This adds complexity. It slows down the initial rollout. But in a high-stakes environment, speed without security is a liability. The deployment of Mistral AI signals a strategic pivot toward sovereign, open-weight AI models in defense. It moves away from the convenience of cloud APIs toward the control of local inference. It replaces the black box of SaaS with the transparency of open weights. It trades the ease of public cloud for the security of secure enclaves. This transition defines the next era of defense technology. It is not just about having a smarter tool. It is about having a tool that you own, that you control, and that can operate in the most hostile environments imaginable. The technology is ready. The frameworks exist. The question is no longer if this will happen, but how quickly the rest of the world will adapt to this new standard of operational sovereignty. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.